Hello everyone, welcome to this short video presentation of my work. The title is The Impact on Different Tasks on Evolved Robot Morphologies, and it's work done by me, Eliseo Ferrante, Jacintha Ellers, Gerben, Meynen, and Professor Eiben. Now, what is this work about? In our group, we do study a lot modular robotics and evolvable modular robotics. The reason we do this is because we're very interested in robotics, but not only from a behavioral perspective, but also what is the optimal body. And so we study the complex interaction and relationship that there is between bodies and brains and how they evolve together. Our design of modular robots is based in reality, so these robots can be built, and it's quite simple. We only have three types of modules. We have a head, a joint, and a brick. The head and the brick are exactly the same, just the head is bigger because it needs to house a Raspberry Pi and logic boards and a battery and a bunch of other cables. But functionally they are the same, and they act as a structural component for the robot to use. So you can build feet and things like this. And for the movement, for the muscle part, we use the joints, which are just powered servos connecting pieces together. Next, so with these robots we already solved the simple tasks, which are locomotion, which is a very common task to solve in this field. But we also looked into different tasks. As an example, we tried to look into rotation, or we tried to look locomotion up a hill, and different things, because we are interested not only in a single behavior but in multiple behaviors. But those behaviors are very simple. We want to do a more complex one. So one behavior that would be very useful, what would actually useful for these robots, is targeted locomotion. For a robot to go to a target and go there. But since we can already develop robots that rotate and robots that can move, what if we create a robot, evolve a robot that is able to rotate and move at the same time, or alternating between one and the other? Then we can have targeted locomotion for free. You just associate the searching behavior with rotation until an object is found, and then locomotion, and then you can move towards whatever you want to go. It's not the most effective, but it's for free. So the next question is, can we do it? Because we evolved different morphologies for rotation and for locomotion and resulted in different robots. So what is a robot that can do both behaviors? And that's really the core of the question of this work. The setup of the experiment was simply by using NSGA2, which is a popular multi-objective optimization algorithm. We defined two different controllers for each robot, and each of the controller tried to solve his own objective. The first objective was locomotion, which was defined by how many centimeters it did in 30 seconds, as in final minus initial distance, and then rotation, which is how many degrees it did in 30 seconds, again only final minus initial. And we considered the results as the values. One very important thing is that the loss in performance is not that bad. That means that robots that did evolve only locomotion or only rotation are better than general robots that try to do both, but not as bad. So we do have some successful evolution of robots that manage to do both. But the real question is, what do they look like? And the answer is a bit more complicated than you might think. You have robots that are very long for locomotion and robots that are very compact for rotation. And when you do NSGA2, you tend to have many different robots. But what's most surprising is that our general robots, they're not really on one or the two, but they tend to be more locomotion, similar to locomotion robots. And so this is the end. We didn't really try to build a final robot, but I want to show you what our robots finally look like. These are the best robots across the runs, and these are all the generalists you can find. So thank you very much. and have a nice day. Bye.